For this project, we developed an RFID material identification system. The purpose of this device is to determine if a worker has been authorized to use a material. Workers are given an RFID card that lists which materials they are allowed to use. When the worker wants to use a material with the machine, they must insert their RFID card into the device. The information in the worker's RFID card is compared to the information in an RFID tag that is attached to the material. If the information matches, then the device will allow the machine to be turned on. This device can help reduce wasted materials and labor time by preventing workers from using the wrong materials.
We have used an Arduino Mega as our microcontroller for this project. It offers a 16 MHz clock speed, 256 kilobytes of flash memory, and 54 digital pins. Our project uses only a small portion of these resources and could easily be implemented on any of the smaller and cheaper Arduino boards. To read the RFID cards, we are using two RC522 RFID readers. These readers are able to detect and read information off of RFID cards brought within 2 or 3 centimeters at a rate of 1200 bytes a second. To display the current state of the program, we have 4 LEDs attached. There is a separate indicator light for 3 possible states. 1. The card is present and we are waiting for a second. 2. 2 cards are present, but the information on them does not match. And 3. 2 cards are present and the information does match. The 4th LED on the far right is attached to our main output pin, which can be used as a control signal for a larger system, enabling machines or devices.
For this project, we used McVicar Classic RFID cards. These cards are available in a number of different shapes. Our examples include a credit card sized and keychain version. The cards we are using offer 1024 bytes of storage split into 16 sectors. Each sector is protected by 2 different 8-byte keys that can be programmed to allow operations such as reading the sector or writing to the sector. In addition, the first 16 bytes of the card contain the serial number and other manufacturing data. This reduces the net storage capacity of the card down to 752 bytes. The encryption used by the McVicar Classic cards is called Crypto 1 and has been broken for several years. However, for the purposes of this project, the encryption is sufficient to prevent accidental tampering of the data in the card.
We have 2 RC522 RFID readers to read information from the RFID cards. These readers communicate with the cards at a radio frequency of 13.56 MHz. All of the power needed by the cards to read and transmit is provided via induction by the RFID reader, removing the need for a battery on board each card. The RC522 communicates to the Arduino using Serial Peripheral Interface, otherwise known as SPI communication. Both readers share data lines in and out, but have unique slave select and reset pins assigned to them. To communicate with a particular reader, its select pin is set to low and all others are set to high. This interface allows many peripheral systems to share input and output pins, and is ideal for smaller microcontrollers that have a limited number of output pins. Information from the RFID reader is returned at a rate of 1200 characters a second. With 2 cards to check and 16 characters on each, we have an upper limit of 36 comparisons between 2 cards every second. This is more than enough for our purposes.
During use, the device continuously checks both readers to see if there is a card present. If there is a card present, the device reads the ID number of the card and the 16 characters contained in block 7. If there is only one card present, then the device waits for a second card to be placed on the other reader and a waiting light is triggered. When 2 cards are present at the same time, the device compares the 16 characters in block 7. If the characters match, then the device sends an enable signal to the output pin. If the information does not match, then the output pin remains low and a warning light is triggered.
Let's take a look at the system in operation. The keychain contains the correct permissions for one of the cards, but not the other. First, we will select one of the cards and slide it into the housing for one of the readers. The middle LED lights up, signaling that it has been found and the system is waiting for a second card to be produced. Now, we will take the other card, which does not contain the correct permissions, and place it on the other reader. The waiting LED goes out, and the leftmost LED turns on to signal that the input is not correct and the system is locked. Note that the system output, shown by the far right LED, is not lit up. Finally, we remove the incorrect card and replace it with the keychain. The two LEDs on the right turn on, showing that the input is correct and that the output has now been enabled. An external device could now use this as a control signal to turn on and off the device. Thank you for viewing our presentation on our RFID material identification system.